कलरिंग अब कुछ बहुत ज़्यादा मुश्किल नहीं रहेगी. ओके, अब हमने 6 कलरिंग प्रूव करनी है फॉर प्लानर ग्राफ. यू हैव अ वर्टेक्स, you already proved that this vertex has degree, there exists a vertex which has degree at most 5. इसके आगे वाला जो काम है वो एक्चुअली हम प्रूव कर चुके हैं, राइट? हमने अभी प्रूव किया है कि chi of g is less than or equal to delta of g plus 1. okay, but अब यहाँ पे ये delta is the small delta, okay, it's not the large delta, which means कि हमें थोड़ा सा इसको tweak करना पड़ेगा. Okay, so what do? We find a vertex which has degree 5. This guy has 5 neighbors. If I remove this vertex, I'm left with a graph which is also planar. Okay, planar graph में से अगर आप एक vertex को remove कर दें तो अपने उसके अंदर कुछ edges add तो नहीं किया, तो your graph is still planar. अगर उसकी पहले drawing exist करती थी तो अब भी इसकी drawing exist करती है, which means कि by induction I can color this graph with 6 colors. Alright, but उन 6 में से I use 5 on the neighbors of V. Okay, और जो मैंने 5 यहाँ पे use कर लिए हैं, it gives me कि there is one color left for V and I color the sky with that color. And that's it. That completes the proof कि I can color. अब base theorem में उसका base case है वो मैंने proof नहीं किया, तो you can do it if you want. I don't know. So the most basic planar graph is a graph on single node, and it's definitely colorable with 6 colors if we put our combined intelligence to this task. All right, so this completes the proof that we can color the planar graphs with 6 colors. Turns out you can do it with 5 as well, but I'm leaving that as an exercise, an ungraded exercise. You just need to go one more step. All right, I'm tired. I've had enough. Questions? Questions, people, questions.
Sir, someone has raised their hand. I think it's Anas.
Okay. Oh, I'm listening. Obed, if there's a question in the chat, let me know.
Sorry, it was an accident.
Okay.
सर मेरा एक सवाल है कि हमने जब when we started the lecture you told कि किसी भी ग्राफ की exactly निकालना कि वो कितना colorable है, it is difficult. So
Yes.
what this whole discussion made possible is कि हम अब जो planar graphs होते हैं उनका हम निकाल सकते हैं exactly, या उनकी भी हम upper bound निकाल सकते हैं कि इससे कम ही होगा.
Very good question. So here is the thing. अभी हमने ये prove किया है कि every planar graph can be colored with 6 colors. Okay, and I told you that actually with a more rigorous analysis you can, using the same proof, prove that 5 colors are enough, or 4 color theorem says that it's actually 4. Okay, and then the proof is beyond the scope of this class, that you can color the planar graph with 4 colors. अब हमें ये पता है कि अगर कोई ग्राफ है और वो 2 colorable है तो we can easily check. अब the problem is कि if I give you a graph and G is planar, तो मुझे ये पता है कि chi is definitely less than or equal to 4. Okay, or I can definitely check whether it's 2 or not. So the question remains, is it 3 colorable or not? Is it okay? So that's the question. मुझे ये पता है कि 4 colors से तो मैं इसको कर सकता हूँ, और 2 से I can check कि ये मैं कर सकता हूँ या नहीं कर सकता, right? 2 से कर सकता हूँ, I'll let everyone know कि it's a 2 colorable thing. But now the question is it 3 colorable? And the interesting part is no one knows. It's still an open problem whether a planar graph is 3 colorable or not. Okay, so even for planar graphs, this question still is open. Okay, मैं आपको एक ग्राफ देता हूँ. The question is it 3 colorable or 4 colorable? 4 colorable तो definitely है. four color theorem says that I can color it with four colors, but can I save that one color? We don't know. It's an open problem for people like you to solve.
सर तो मतलब वो जो यूएस वाला था उसके अंदर उन्होंने बस 4 कलर्स दिए और उनको बस ऐड कर
Yeah.
दिया.
So in practice, what people do is they say, okay, so they try to do it with 3. They enumerate it, and then they just say, okay, in the worst case, we are using one extra color. Okay, but if it's a simple graph, अगर कोई बहुत ज़्यादा बड़ा नहीं है जैसे यूएस की स्टेट्स हैं, तो फिर it's not that hard to check. Okay, you can actually figure it out, okay, whether you need 4 colors or not. Most of the in most of the maps you actually do need 4 colors. So इस तरह की situation arise कर जाती है. Where is that down picture? So इस तरह की normally picture maps में अकर कर जाती है अक्सर जगहों पे geographically naturally. तो this means के 3 colors तो use नहीं कर सकते आप, right? But you can definitely create complex planar graphs for which it's really hard to tell okay, they are 3 colorable or not.
सर इसमें हम बस डिग्री नहीं देख सकते कि अगर हाईएस्ट डिग्री 3 है तो मतलब
That does
definitely
not
4
help
ही
you.
होगा.
That does not help you. So even if the highest degree is not 3, it's still, I mean, ये तो आपके पास canonical है ना. If you have a K4, so you definitely need 4 colors, right? But even if K4 is not there, it might still be not 3 colorable. All right. So, but the thing is, देखो highest degree वाला जो आपका argument है ना वो यहाँ पे नहीं चलेगा. You can have a planar graph जिसमें highest degree बहुत ज़्यादा है. So let me try to make it somewhere here where I. So for example, over here, so if look at this graph, okay, this guy has I don't know. You can make its highest degree 100, okay, but still it's a planar graph, right? So that does not help you. The highest degree formula will say, okay, you need 100 colors, right? That's not good enough. So,
okay, got it.
yeah, highest degree check does not help. The K4 check does not help. Nothing that we know seems to help. All right, people. I suggest ये आपके पास last कुछ दिन रह गए हैं तो let's push it. Let's give us our best. I'm around if you need me. I'll definitely meet you. I'll set aside मेरे बाकी जो काम है research वगैरह. If you need me, तो I'll try to make myself available. Okay, but you need to be there for your part or give your 100%. Okay, it's not much हमने जो cover किया है. Videos already there. Topics आपको पता है, homeworks आपके पास हैं. So if you just spend enough time, so I think we can make it. Okay, and all of this is going to be really useful in your future classes as well. आपने algorithms पढ़ना है next semester में, तो it's very useful. उसमें major part जो है algorithms में वो graphs के हैं, तो we'll use that. You'll use that there as well. Okay, in general these are interesting problems जिनकी applications ऑपरेटिंग सिस्टम्स में है, सिस्टम प्रोग्रामिंग में है, मशीन लर्निंग में ऑफ कोर्स है, एआई में, साइबर सिक्योरिटी में. हमें द प्रॉब्लम विद द डिस्क्रीट स्ट्रक्चर इज के ऐसा कोई लाइन नहीं है, कोई एक काम आपने नहीं करना होता. ये सारी इन जो आपने फ्यूचर में क्लासेस पढ़नी है उसमें जो जो कुछ जो आपको चाहिए होता है वो हमने कंडेंस करके इस क्लास में आपको देना होता है. So it's sort of like a bunch of things. they are not linear. वो कोई एक path नहीं बनाती, तो आपको बहुत सारी इस तरह की चीज़ें देखनी होती हैं. But somehow they are useful in the advanced classes. So if you miss this chance, so it's gonna be probably um, hurtful to you in the future classes. तो इसलिए especially graphs are everywhere. आप जहाँ पे भी you can't save yourself if you try to remain in computer science. You can't save yourself from graphs. So yeah, so I would, I don't know, suggest you to spend whatever time is left to give your best. Okay. All right. See you on Monday formally. And informally, if you need me, I'm available. Okay.
Okay, sir.
Thank you, guys. Allah Hafiz and good luck.
Allah Hafiz, sir.